Hi, my dear children. Hope you all are doing well. Welcome to the second session of Digital Electronics class. Last class we discussed basic logic gates, AND gate, OR gate, NOT gate, their logic representation, truth table, switch representation, and also construction of OR gate and AND gate using diodes and NOT gate using transistors. Hope you all understand these topics. Now moving on to our next new topic, universal logic gates. Universal logic gates, why the name is universal logic gate is that we can construct basic gates, that is AND gate, OR gate and NOT gate using universal logic gates. NAND gate and NOR gate are widely known as universal logic gates. So first, NAND gate. NAND gate, from the name itself, it is NOT AND gate. So this is the logic symbol of NAND gate. You can see it is an AND gate with bubble here. That is bubble AND gate. It is known as a NAND gate. So the inputs are A and B. So you will get an output A dot B all bar. That is, the output of NAND gate is the complement of output of AND gate. So this is the truth table representation of two input NAND gate. So if it is two input, we have four possible conditions. In an AND gate, as we studied earlier, we will get a high output only for one case. That is, if the two inputs are high, then only we will get an high output for an AND gate. So in this case, that is in the case of an NAND gate, the output will be low only if both the inputs are high. That is, for other inputs, that is, if any of the input is high, you will get a high output for a NAND gate. Okay. So this is the truth table representation of NAND gate, and you can see you will get a low output only for one case, that is the last case, that is if both the inputs are high. This is the three input representation of a NAND gate and its truth table. Here the inputs are A, B and C, and the output is A dot B dot C, the whole bar. Now let us check the truth table. So if it is a three input, we will get 8 possible conditions. So your output will be low only for one condition, that is if all the inputs are high, and else it is high output, that is the output will be high for a NAND gate if any one of the input is high. This is the output of NAND gate. This is the output of AND gate, and you can see it is just the complement of, that is, this is just the complement of this column. Now moving on to our topic, that is we are going to construct NOT gate, AND gate and OR gate using NAND gate. So you already know this is the logic symbol for a NOT gate. This is the input A and this is the output A bar, and this is the truth table. So if input is low, the output will be high, and if the output input is high, the output will be low. So if here it is 1, if we are going to check the truth table, if it is 1, the output will be 0, and also if it is 0, the output will be 1. OR gate using NAND gate and its truth table. This is the logic representation of an OR gate, and this is the truth table. In an OR gate, the output will be high if any one of the input is high. Okay, so we are going to construct an OR gate using NAND gate. In this case, we should use 3 NAND gate. In the first NAND gate, the input is A, and the second NAND gate input is B. So we are going to cross check the truth table. So first case is if A is 0, B is 0. If A is 0, B is 0 means here the output of will be 1, 1. And we are giving this output as input to the third NAND gate. So 1 1 means the output will be 0 for a NAND gate. Next case is 0 1. Here A is 0, B is 1. The output will be 1 0 1 0. Now we are giving this input, this output of first and second NAND gate as input of the third one. Okay, so 1 0 means the output will be 1. Next is last case. Let us check the last case, 1 1. 1 1 means the output will be 0 0, and output will be this output will be giving to the third NAND gate as input. So the output will be 1. So last case 1 1 0. That is, let us check again. So 1 1 means here it is 0 0. 0 0 means the output of AND gate it is 0. But here it is NAND gate bubble here. Therefore it is 1. So we will get a high output 1. So in this case we will get a low input only for one case, that is if both the inputs are low. This is the same condition for an OR gate. Next, AND gate using NAND gate. This is the logic representation of AND gate, and this is the truth table that we studied earlier. And now we are going to construct AND gate using NAND gate. So here we use two NAND gates. The first NAND gate, A and B are the input, and the second NAND gate, A dot B will be the output. So we are going to check the truth table. First case 0 0. So what will be the output of here? It is 1. 0 0 means the output of AND gate it is 0. But here it is NAND gate. So the output is equal to 1. When it is given to this, it just complements, that is 0. Next case 0 1. 0 1. What will be the output here? It will be 1. So 1. This NAND gate complements that input and we will get an output 0. Let us check the last case 1 1. 1 1 means the output will be, what will be the output? If it is for AND gate it is 1, but it is a NAND gate here, so the output will be 0. That 0 we are giving to this second NAND gate, so we will get a 1 output. So in this case we will get a high output only for one case, that is both the inputs are high. This is the case, exactly the case for an AND gate. Hope you all understand this topic. That is, today we studied universal logic gates, that is NAND gate and NOR gate. They are known as universal logic gates. So in this class we studied NAND gate. NAND gate is nothing but not AND gate, and we studied the logic symbol, truth table, and the construction of OR gate, AND gate, and NOT gate using a NAND gate. Why they are known as universal logic gate means we can construct basic logic gates, that is AND gate, OR gate, and NOT gate from these gates. Thank you.